Taylan Kargın from Bilkent University, and I'm going to present my EE102 Digital Design course project. My project is a digital audio equalizer. An audio equalizer displays the frequency components in an audio signal. It shows this frequency spectrum of an audio signal. Before I start explaining details of my project, I want to explain what a frequency spectrum means. A frequency spectrum, actually, according to Fourier's theorem, any continuous analog signal can be represented as sum of sinusoids with different frequencies of different amplitudes. Therefore, we can use Fourier transform to extract the frequency spectrum information, which shows us how different frequencies have different amplitudes in a given signal. So, I want to show a brief demo of my equalizer. Okay, so let me explain what does this project do. I get my audio signals from my computer. I split these signals. One branch goes to my basis tree. One branch goes to an external speaker to listen what music plays. And the branch goes, the branch that goes to my basis tree samples my analog signal to discrete digitalized signals using analog to digital converter inside my basis tree board. So my board discretizes and digitalizes these signals, and then it uses these signals to process the data. You can see this 7-segment display shows the amplitude of the given signal, and this lets also show the amplitude of given signal, and the processed data is sent through my VGA port. My VGA, you can see the frequency spectrum of this data. Each line represents different frequencies. For example, this line, the leftmost line, represents my component with 0 frequency, which corresponds to DC component. So it is a high DC component, and the frequency values increases like this. So from 0 to 24. So if we have a sound with lower frequency, its graph will be like this. Its graph will be here. But if it has a higher pitch, its graph will be here. So let me just play another music for demonstration purposes. Okay, so any sound signal can be expressed as a frequency spectrum histogram. So it basically works like this, but actually what I propose is a different project. I propose that I can arrange the amplitudes of different frequencies, like with different potentiometers. Like if I want to get more bass in my sound, I propose that I can use a potentiometer to filter high frequency components and allow to pass lower frequency components, but it requires a lot of memory that my basis tree cannot doesn't have. So but I just created a simulation, a test bench simulation, to show how it works. You can see I created a square wave with 7 sinusoidal sum. So I actually take the Fourier transform of the signal first. Let me show. This is the Fourier spectrum of my signal. As you can see, the square wave consists of 7 different sinusoids. Then I apply a filtering procedure. Here this values here shows my filtering values. So this is first I apply a high pass filter. So my signal is filtered and only high frequency components are allowed to pass. So the resultant signal is this. After that I apply a low pass filter and my result signal is this, a pure sinusoid. And it goes like this. I apply different filters. For example, this is all pass filter. I get the original input signal. And then I apply different filters again. But the important thing is that the filtering procedure is done in frequency domain. So I first get forward Fourier transform of my signal and then apply a transfer function to it by multiplying with a transfer function, and then I get a new frequency domain here, and then get an inverse Fourier transform to get an audible signal. So this is what I propose first, but my basis tree board has not enough memory to implement this, so I just implemented first forward Fourier transform of input signal. So that's all. Thanks for watching.